All right, let's start wrapping this stuff up. Now we're just going to create stuff. We're going to find a power series representation for the following. Just make it. There you go. I'll just let you go. Take the T, the A, the N, that -1, and the X. Move them all around and go give me a power series representation. Well, do you know the derivative? Did you know that this is the integral of 1 over 1 plus x squared? Did you know that? You knew that, didn't you? I mean, it's true for a plus c, but we don't care about the plus c. You know that? You knew that. You knew that. Well, what we'd like to do is create something for this. We're going to say, let this be our f of x, the 1 over 1 plus x squared. And we're going to use the idea from before. Do you remember that 1 over 1 minus x is equal to the sum as k is equal to 0 up to infinity of x to the k, which is equal to 1 plus x squared plus x cubed plus ... And we've already seen this one before. So our game is going to be, you find the derivative of our function. It's right there. And we're going to find a power series representation for that, and then we're going to integrate it, and then we're going to get a power series representation for inverse tangent of x. So this is the same thing as 1 over 1 minus our -x squared. We've done this. You're like, okay, cool. So 1 over 1 plus x squared is actually equal to the sum as k is equal to 0 up to infinity of not just that. We're going to plug in, oh, I don't know what that is. Oh, if you try and jump to that part, you're not going to get the right answer. We actually just need to jump and plug it in here. So our first term is 1. Our next term is just x. But our x is -x squared. And then we're going to add it to something squared plus something cubed. And put our -x squareds in there. And we write plus ... because it's an infinite thing. And then we're like, oh, here it is. It's 1 minus x squared plus x to the 4th minus x to the 6th plus x to the 8th minus ... And it goes on forever and ever and ever. Cool. Cool. But look back at the beginning. If we integrate this thing, if we integrate 1 over 1 plus x squared, we're going to get inverse tangent. So inverse tangent will just equal the integral of this. So that's x. That's x cubed over 3 plus x to the 5th over 5 minus x to the 7th over 7 plus x to the 9th over 9. And then there's a pattern emerging. We've now just found a power series representation from inverse tangent by messing around with this derivative. Because we knew its derivative. Oops, one more for you down there. I want to save the fun. Now, can we write this as some sort of sum? Well, let's start at 0. I want to start at 0. I think it's going to work out nicely. So let's look again. So this is the 0th, the 1st. I'm telling you, it's super helpful to write what term it is up above. So we're like, okay, let's just deal with the signs because they're oscillating back and forth. So evens, 0, 2, 4. I think 0 is an even number. Those are all positive, and the odds are negative, so that means we're going to use a -1 to the k. Now, what's going on down below? On the 0th term, we had a denominator of 1. On the first term, we had a denominator of 3. On the second term, we had a denominator of 5. On the third term, we had a denominator of 7. And on the fourth term, we had a denominator of 9. How could we do this? Well, that's saying it's 2k plus 1. 2k plus 1. To create odd numbers, it's either 2k plus 1 or 2k minus 1. That's how you create a sequence of odd numbers. And this one's going to be a 2k plus 1. Check it out. You plug in 0, you get 1, right? When k equals 0, you get 1. When k equals 1, you get 3. When k equals 2, you get 5. So there's our bottom. We're going to say it's 2k plus 1. And now we have to figure out, I could have done that first. We got to figure out, well, what the hell is going to be the exponent? The exponent and the denominator match. X to the 2k plus 1. That's inverse tangents power series representation. -1 to the k times x to the 2k plus 1 divided by 2k plus 1. And of course, it's the sum from k equals 0 up to infinity. That is our approximation. And it's weird. We didn't solve that one. We actually went through because we knew its derivative. We wrote its derivative's power series. Then we integrated the power series so we could get back to inverse tangent. All fun stuff. We'll only do this for a little while, and then we're just going to give them to you. Be like, this function equals this function equals this function equals that. And go, so you don't have to do this by hand every time. Now, what on earth are we going to do? And now, in the interest of time, I'm going to skip some things here. Do I have the problem up I want? So hold on. Let me make sure these all work. Yeah, the plus one's up top. So we want to find the power series representation for this. Now, we won't have to find any derivatives or integrals here. I think this is just going to be a little bit of straight algebra. We're finally going to do some sum and differences. So we can call this the same thing as ln of 1 plus x minus ln of 1 minus x. So we can take the sums of these terms. Yeah? Haven't we? Haven't we? Uh-oh. Maybe we will have to take derivatives. But I think we've already done some of this. Yeah, we have done some of this. Sorry, let's go and look. ln of 1 plus x and ln of 1 minus x. Didn't we do this before? Not the ln of 1 plus x. We haven't done that one yet, but we did this in a previous, so I'm going to skip to it. So ln of 1 minus x. You know, that part right there? I want to skip to it. Because, well, these videos are too freaking long. Remember that? Remember I took out the negative? And it goes on forever? Well, let's use that same logic to take care of our ln of 1 minus negative x, aka 1 plus x. Oops, negative inside of there. Well, this one's going to turn out to be negative x minus negative x squared over 2 minus negative x cubed over 3. So this turns out to be x minus x squared over 2 plus negative x cubed over 3. If you were to continue on, you get x to the 4th over 4, but negative, and the next term would turn positive. So we have the two of them. So let's kind of just write them out. We have ln of 1 plus x minus ln of 1 minus x. All right, from right above. That's what we're trying to find out. So let's pop this in down below. We're like, well, this is equal to negative x minus x squared over 2 minus x cubed over 3 minus ... and it continues on. And I'm just going to use a little parenthesis around it. And then we're going to subtract out. Oops, I wrote the wrong one. It's the 1 plus x goes first. I wrote the wrong one. We want the 1 plus x. We want this one first. My bad. My bad. I'm not redoing this. Sorry, I'm almost done for the day. I'm very happy about that. I'm going to go rock climbing today. So there is our ln of 1 plus x. And now we're going to put in our ln of 1 minus x, which is negative x minus x squared over 2 minus x cubed over 3 minus ... And it goes on forever. So let's start... let's bring in our negatives and let's just see what happens. We have x minus x squared over 2 plus x cubed over 3 minus ... And what do we get over here once we distribute that negative in? We're going to get a positive x a positive x squared over 2, a positive x cubed over 3, plus, and it's going to go on forever and ever. We just turn them all into negative, or all into positives. So let's put them together. Let's just look at our terms. Let's combine like terms. So we have x plus x, and well, that's 2x. Now we have negative x squared over 2 and positive x squared over 2. Those are going to go away. They cancel. And then next, we're going to have our x cubed over 3 plus our x cubed over 3. So I think we're going to end up with plus 2 times our x cubed over 3. And then we'd lose our x to the 4th because they'd be different signs. Then we're going to end up with 2x to the 5th over 5 if you continue the pattern. And there we have it. We now have combined into 2. Now let's see if we can't figure out what our power series representation would be. Well, let's factor out the gosh darn 2. They're in common on all of them, so let's take it out. We have 2 times. The sum is k is equal to something. Let's go 0 up to infinity. And let's just think about it this way. We've just lost our 2's. Can you come up with a power series representation of something to the first power? So this is our 0th, our first, our second. It's 2k plus 1. They're odd numbers. How do we represent odd numbers? 2k plus 1. Thus, our top will be x to the 2k plus 1. Fortunately, all the powers and denominators match, so we're going to be left with 2k plus 1 down below. And there is our power series representation for, oh my goodness, ln of 1 plus x divided by 1 minus x? All inside that natural log? Oh my goodness. Look at you go. What badasses. Huh. Seems really similar. Look how inverse tangent and ln's, man, they look pretty similar in there, but they're different. They're not the same thing. So we've made it. We're to the end. Actually, a lot. I'm going to make one more video just to show you how we can integrate something that's not integrable, and then we'll move on to 11.3. All right, see you.